everybody.
Hello. Hi, Jesus.
I wanted to say hello, Jerry, before the event starts. Hey, and thank you for coming to say it.
Yeah, no problem, man. I'm happy to do it.
Okay, good.
Hey, Nico, did you want me to pop up my presentation now, or?
Yeah, yeah, you can put it up, okay. And we will start around 12:05. Yeah.
Cool. I think you need to give me permission.
Oh, yeah.
I don't think I would see any issue. I wouldn't work, you know. CM Punk. I think someone called him too, right? Punk is ready to go. That is growing in the U.S. and Canada. Carbon stored in the wood is 171 metric tons of carbon dioxide. The avoided greenhouse gas emissions is 66 metric tons of carbon dioxide. Total potential carbon benefit is 237 metric tons of carbon dioxide, which is equivalent to, this is really cool, 50 cars off the road for a year, or energy to operate 25 homes for a year. So it really makes it relatable, right? And so you can see there on the left, that's our new-ish website for the WoodWorks program. And then on the right-hand side, that's the CWC website. So I invite you guys to go check those out for some really great resources. This is the WoodWorks website. We have this e-learning center, so which is great. There's a ton of like pre-recorded seminars and presentations on there. And so if anything with wood-related presentations, if you're concerned about maybe some acoustics with wood frame construction, you can register to on the site, register, and then you can watch some of these presentations. Okay. We also do webinars, host webinars, and so we've been doing this for a while now. On the left, you'll see that those are some of the past ones. On the right, this is actually our newest one that we're going to be hosting on Friday, February 19th. So if you guys are interested in that, these webinars are free for you guys to attend. All you gotta do is go to our website, wood-works.ca, register for the event, and show up. This is our program. We are a national program, but we do have teams in BC. So you'll see we have a team in BC. Here in Alberta and the prairies, there's only two of us, myself and my colleague, Rory Koska, who is the program leader. And so we cover quite the territory. We cover actually Alberta, Saskatchewan, and Manitoba. We have a Ontario team. We have a Quebec team, which is the Secobois program. We have an Atlantic team, and then of course our national team, the CWC, based in Ottawa. We're a mature program. We've been around for 18 years and longer. During that time, we've helped influence over 1 billion board feet of lumber, 471 million square feet of panels, $8.5 billion worth of commercial projects, which translates to $558 million worth of wood sales. And then we're continually doing education for the design community and for post-secondary and students as well too. And how we deliver the education is through activities like this, lunch and learns. Once upon a time when we were able to meet in person, we would spend the lunch hour with the design community. So, you know, engineering firm, architecture firm will invite us in. We'll feed them for that hour. We'll educate them for that hour, and then they'll be on their way. And then they, with the architects and the engineers, they actually are able to get learning credits to keep up with their professional designations. Design seminars. We host these design seminars. These are pretty cool. These are either morning sessions or afternoon sessions. And this is where we'll bring in like 3 international speakers to talk about their wood projects. And then, yeah, again, we feed you guys and educate you guys. Wood design workshops, these are geared more towards the engineers. And so these are either full day sessions or 2-day sessions. They're very technical. And so we usually have the engineers either bring their laptops or and calculators and whatnot, and they're actually doing calculations and learning at these workshops. So these are pretty intensive workshops. This one here, for some reason, this was our most popular event. So we held this event in Edmonton and in Calgary, and this sold out. It sold out within a couple of days, and I'm guessing it has something to do with the engineering part. And so this was really cool. We held this at a pub in Edmonton and a pub in Calgary. We brought in a hydraulic press. And what we did was we had these wood samples. So we had samples of CLT, we had samples of glulam and with different type of connections. And we actually did the design of these connections first. And then we actually put the hydraulic press to use, and we actually broke these connections. So it's very interactive. It's hands-on workshop. Again, it's a great workshop. And it's amazing that, with the engineers, no offense to any of the engineers out there, but generally they're very professional and very, just straight up and very business. And it's amazing how, once you have a few drinks and then they start to loosen up and are willing to share and talk about their projects and whatnot, right? And so that's kind of the whole purpose of these events is, to allow the design community to get together, to network and to learn. Okay. We also provide these case studies. I showed you guys one earlier of the Philip J. Curry Museum. So you can find these online. These are on our website. And again, some great resources for you guys, free downloads, right? We also celebrate the architects and the engineers and the design community. We hold a Wood Design Awards every year. And then so the designers submit their wood projects into different categories, whether it's like commercial building, educational building, institutional, whatnot. And then we fly in a jury, some jury members, and then we sit in the boardroom and we deliberate all day and come up with the winners of each category. And then from there, the winners of each category are celebrated at our gala. And also the winners get published into this really awesome awards book. And so these awards book are pretty amazing. If we were in person, and if I was in front of you guys, I would actually be giving some of these away to you guys. These are great books, and just really inspirational and whatnot. And so the winners get published into that. We also hold our annual conference and trade show, which is called the Wood Solutions Fair. Again, just a full day of networking, learning, and then visiting with all the different wood suppliers, manufacturers, and just checking out some of the award-winning structures that are being presented on. And in fact, our Wood Solutions Conference, what we do every year is because of our partnership with the student outreach, and I'm not sure, Nico, if it has been announced yet or not, but we are supporting the wood design competition again this year for the students. And sounds like somebody's watching TV or something. So with the student wood design competition, we sponsor this every year. So we provide some financial support, and then the instructors at SAIT turn it into a design competition. So you can see that these are some of the previous winners. And also what we do every year is we invite all the winners to display their winning projects at our Wood Solutions Conference. So again, it's just a great way for the students to get their faces in front of the design community. So at our conference, it's all architects and engineers and principals and owners of firms. So if you happen to have one of these winning designs, to be able to showcase what you're capable of doing to these potential owners and principals of firms, make a case for yourself to go work for them, right? And so in the past, we have had a lot of the students that have displayed actually land jobs through the Wood Solutions Conference. Okay, so we're a global network. Our network is a global community of designers, builders, manufacturers, suppliers that have anything to do with wood, all right? So now let's get into why wood. Well, there's over 7,670 million people on the planet right now. And 3 billion of these people will need a home by 2035. So that's roughly 100,000 homes a day that need to be created, right? And so by 2050, the world's population will see an additional 2.5 billion people move to cities. North American cities are already booming due to urbanization, and architects, developers, and planners are being tasked with accommodating the increasing demand for space to work, live, learn, and play. So we will be 70% urban by 2050. So we require some solutions for these dense urban contexts, and urban sprawl is not usually an optimal solution. So it's critical that cities build up rather than out. Okay, and so for this pace of growth and development to be sustainable, it's essential that that we rethink environmentally taxing traditional steel and concrete structures, and we look to some of the wood innovations that are offered for taller structures that are high performing and renewable to meet the coming demand. So the building industry is responsible for roughly 40% consumption of the world's resources, 25 to 40% consumption of energy, 30 to 40% emission of greenhouse gas, 30 to 40% of solid waste generation. Okay, and the building industry uses mostly concrete and steel. Of that, concrete is responsible for roughly 5 to 8% of global greenhouse emissions, and steel is roughly responsible for 4% global greenhouse emissions. Add to that the airline industry at 1.6 and shipping another 3%. So we got some really big problems, and it's posing some big responsibilities to not only the design community, but also provincial governments, federal governments, municipal governments. But it's also posing some really big opportunities. And some of these big opportunities I'm going to discuss with you guys. One of them right away here, which is a really awesome opportunity, which is going to make us all millions if you guys want to join my team. Okay. So you know, there has to be like a systemic change in the way we the way we build, right? And we think that wood is a viable alternative to steel and concrete. Wood as a material, it's preferred. It's a preferred building material for residential construction. It has been for, you know, for decades, for centuries, in fact. New engineered wood products, EWPs, and code changes have increased the share of commercial markets, and new building systems and technology have been developed to push into the future of wood construction. Mainly, we're going to be talking about mass timber panels. Okay. So timber is a you know, it's a time-tested structural system able to withstand the forces of nature, such as like earthquakes and wind and fire. And many of the mass timber buildings shown here are not only old, but are, you know, quite beautiful actually. And so there's nothing new about using timber as a durable, dynamic structural system. You can see we've been building with wood for the past 1,400 years. We all kind of know the life cycle. It's like when a tree is cut down, you know, through photosynthesis, there's carbon in there, and so the carbon it's sequestered during its life cycle is retained within its cellular structure, right? And so the carbon it contains, it's then placed in a dormant state, and so it's removed from the atmosphere for, you know, the life of that wood, so for decades, right? So the manufacturing of wood products basically results in the storage of a portion of the tree's carbon in long-term storage media, such as like houses and buildings and furniture. And the carbon is only released back into the atmosphere when the wood is burned or when it biodegrades. So 1 cubic meter of timber can hold roughly 1 ton of CO2. So your typical 2,400 square foot wood frame house holds approximately 28.5 tons of carbon dioxide, which is an amount equal to the emissions of a small car over 5 years. So more than half of Canada's forests are naturally reforested, okay? And so natural regeneration is supplemented by planting of, okay, remember this number, 600 million seedlings per year, okay? That's Canada, Canada-wide, 600 million seedlings per year. Over 30 different species of trees are used in replanting activities across the country to remain faithful to the natural biodiversity of each area, okay? So the rate of growth in Canada, the commercial forests, so you can see here that in this hour lecture that I'm giving you, the forest in Canada would have grown enough wood to supply over 2,000 houses in an hour, okay? And so in Alberta, we plant roughly 2 to 3 seedlings for every 1 tree that we harvest. So approximately 65 million trees are planted every year just here in Alberta alone. Forest companies are required to have these long-term plans, okay? And so because of the land is crown land, and so a lot of these forest companies lease the land for 50, 100 years, 200 years. And so the province and the feds require to them to have these harvest plans. So they have to have 25-year plans, 50-year plan, 100-year plans, and a certificate is only issued after a thorough review by third-party auditors determines that, among other things, that long-term harvests are sustainable and there is no unauthorized or illegal logging, and that the wildlife habitat is preserved and soil quality is maintained. Okay. So now I'm going to talk to you guys about this one of the big opportunities here. And if you guys want to team up with me, just shoot me an email afterwards, and we'll team up on this. Okay. Here's the big opportunity. You ready? Just the other day, Elon Musk launches this $100 million carbon capture competition. I think we all know who Elon Musk is, right? And if you don't, you've been hiding under a rock, because just recently he became the world's richest man. And so anyway, so basically the overall aim of the contest is to produce a device that can remove 1 gigaton of CO2 from the earth per year. Okay. And so if you don't know what a gigaton is, it's 1 billion tons. Okay. 1 billion tons of CO2 from the earth each year. Okay. Now, he said this in quotes: any carbon negative solution is eligible. Okay. Nature-based. Okay. You see where I'm going with this? Nature-based, direct air capture, oceans, mineralization, or anything else that sequesters CO2 permanently. Okay. Now, the winner is going to receive $50 million. All right. Second place, 20 million. And third place is $10 million. Okay. So I did the calculations, and here's what I came up with. There are 3.6 tons of CO2 that is stored in a tree. Okay. And so now if we go and if we divide 1 billion by 3.67 tons, we're going to have to plant 272,479,564 trees. Boom. There's our 50 million. So who's in? Who's in with me? This is what I'm going to, this is what we're going to approach Elon Musk with. Okay. I wish it was that simple, you guys, but obviously it's not, right? But there is a case for more forest and more wood. Okay. Can we agree that wood is also quite beautiful? So you can see some of the images here. You guys might recognize some of these. Top left corner is the Rocky Ridge Rec Center. If you guys haven't been there, I strongly suggest you guys go there. This is in Calgary, so you probably won't be able to do any kind of recreational stuff yet, but once you do, highly recommend you guys go check that out. This ATCO office building is actually also lower corner, left corner, is also in Calgary. Thought I'd put a couple images on here for you guys that you guys can relate with. I'm sure you guys can relate with Autodesk. I believe the Autodesk are the makers of AutoCAD. And do you guys still use AutoCAD, Nico? Yeah, AutoCAD? Yeah, okay. So yeah, Autodesk is using mass timber in their buildings. How about this? I bet you everybody on here has been to McDonald's. Yeah? McDonald's, their global flagship in Chicago, they're using mass timber for a lot of their buildings. This is also in Calgary. This is beautiful. If you haven't gone there, then you probably don't like reading books, but you should go there. And it's the beautiful, beautiful library, you guys. We actually held a few of our design seminars here, and it's just a wonderful space. If you guys like to pray, go check out this church. It's actually in California, but maybe you need to go pray for some good marks. for your design competition and whatnot. So why not pray in there? And then this other project on the lower portion is called the barn. And so wood also has this natural benefit. It's a natural insulator. Okay, and so it contains a natural honeycomb of millions of tiny air spaces within the fibers. So if you were to gather like a whole bunch of straws together, this is kind of what it would look like if you were to look at a cross section of a tree under a microscope. Okay, so those tiny air spaces within the fibers, all of which they create this natural insulation. Okay, and so wood's been shown to be 400 times more effective than steel, 1,800 times more efficient than aluminum, and 8 times more efficient than concrete. So wood has an R value of roughly 1.5 per inch. Steel has essentially 0 R value. It's like 0.0024 per inch. Okay. Actually, there's also a lot of health benefits too. So wood and health in the built environment is some research that supports wood in evidence-based design. So one of my old colleagues, Dr. David Fell with FP Innovations, did some research at the University of British Columbia. This is while we were with FP Innovations, and he explored the link between the use of indoors and the well-being of building occupants. So if you guys want to read a little bit more on that, you can just Google his paper. There's also a white paper from Commercial Architecture who did a similar type of research as well too. So you can look that up as well too. Basically, what Dr. David Fell's study did was it looked at the psychological stress responses in wood and non-wood environments. So they had these different offices, right? And some of the offices had like wood desk, wood shelves. There was a plant in there, and then the other office was just basically like melamine IKEA stuff, right? And so what they did was they they had subjects in the wood treatment room, and what ended up happening was the subjects in the wood treatment room displayed lower psychological stress responses before, during, and after a stress-inducing test versus the subjects in the non-wood room. Okay, and so the results provide scientific evidence for a new wood attribute, which is health, and wood are intuitively linked by architects and building occupants alike. So what does this mean for building occupants? It means lower sympathetic nervous system activation, which is associated with lower blood pressure, lower heart rate, lower psychological stress, lower susceptibility to illness, and a better ability to focus attention. So doesn't it make sense that we should be building more of our, for example, schools out of wood and leaving the wood exposed? Some of our hospitals where a lot of these patients need to have rehab, wouldn't it make sense to have a lot more of the exposed wood in the buildings? So we require some solutions for these dense urban contexts. And so now we're going to get into some of the solutions which we feel could be mid-rise wood construction and tall wood buildings. And so I'm going to just briefly touch on mid-rise. And so there's extensive mass timber building history all over Canada, and with many of the brick and beam buildings up to several stories in height. Some of these have been built anywhere from like 1859 to 1940. And a bunch of these old buildings are old factories and warehouses, and they've turned them into like unique workspaces or even living spaces. Mid-rise is a tale of regional differences. And so the thing with mid-rise is that it's still fairly new to Alberta. But it's been widely accepted in BC, okay? And so the developers are creating some newer solutions. They're creating these hybrid type of buildings using mass timber and light wood frame products. And I'll be discussing that in a minute here. Ontario, the developers, they're not fully on board yet. They're reconsidering wood. There's the higher prices. of wood in the early 2018, and even now, price of lumber has gone up quite a bit. You know, their codes are a little bit different, so they have to design with non-combustible stairwells as well. I think they have to include some non-combustible materials for their exterior facade as well too. Higher insurance costs. The concrete industry is very proactive over there in the East. Some of their ads and their promos are not wood friendly at all. And the workmanship quality, they're having issues there. And the same thing with Quebec is, you know, again, difficult market to change. They have very, very low concrete prices there. There's a lot of concrete manufacturers there, so their concrete prices are very low. And again, the workmanship, the trades need to be trained over there, right? So you could see here, even though Ontario and Quebec have the majority of the population in Canada, you could see that it's been accepted widely in BC. So these numbers are a little bit old. The numbers are a little bit higher, but even still, you could see Alberta just lagging way behind, right? And so hasn't quite caught on yet here. But you know, obviously, it's the developers are seeing some value in BC, hence why the numbers are much larger there. This is a project in Vancouver. It's the Virtuoso Adira Developments, and so Adira Developments were part owners of a company called Structurlam at one time. Since then, they've since been bought out by a large investment firm out of the States. But with Adira being part owner of Structurlam, they had to kind of practice what they preach, right? And so what they did was they started building some of their developments with the mass timber products that they're producing. So this is a 6-story residential light frame. It's a hybrid, so it's mass timber and light wood frame. It has a quiet floor system, which competes with concrete. There's time savings, so you know, it has superior acoustics similar to that of concrete, just because these mass timber panels are being used for the floor systems and the roof panels. 160 CLT panels were lifted at a rate of 1 every 12 minutes. And so you can see the picture in the bottom below. The guys are installing one of those panels. So they're installing one of those panels every 12 minutes. And so they're able to frame up 4,500 square feet of flooring installed in less than 3 hours. So there's huge time savings there, right? If they were to do these type of floor panels in, let's say, I-joists, engineered wood products, you know, it would take them anywhere from a week to a week and a half just to frame out that whole floor system, right? Whereas if they're doing it with these mass timber panels, because they're covering off such a large quantity, they're able to install a whole floor of floor panels in a day, right? Which allows them to start framing up the walls quicker, sooner. This is another example. This is the Legacy in Langley, BC. And this was a higher end, this was sold as a higher end condos. And you could see that, you know, the CLT came in handy here with, we're cantilevering out those balconies. And they were able to come up with these really crazy curvature balconies. But again, they were able to do that with the CLT because a lot of that was already cut in the factory and then just shipped out to site, right? Now, this is Hockley Ave. This is another Vancouver project. So three of these large 6-story light frame hybrid structures. Now, as a developer, you know, if you're with developers, their biggest concern is costs and making money. Okay, and so if they're going ahead and building 3 of these 6-story buildings, they obviously see the value in this, right? They're not doing this just as a practice trial run. They're doing this because they know that they can make a huge return on their investment. If you guys are ever out in Penticton, I invite you to stay at this hotel. This is the Penticton Lakeside Resort. Another great mass timber building. This is a hotel, 6-story. And the nice thing about using mass timber was because this is on the lake shore, the soil conditions were fairly poor. And so they had to pour piles, right? And so by reducing the foundation load, because they didn't use concrete, they were using mass timber, the whole structure of the building was a lot lighter. And so that they were able to reduce their foundation loads by 60%, which again is savings as well. So we have some of these solutions. Going to be talking about some of these new products with enhanced properties, which is going to allow the developers to build quicker, meet and exceed structural and fire requirements, can be cost competitive, and we can use these in mid-rise buildings. Mid-rise is considered 5 to 6 stories, and tall wood is considered anything 7 and above. Mass timber construction uses large and ideally prefabricated wood for walls, floors, and roof construction. And because of their high strength and dimensional stability, they can be used as alternatives to concrete, masonry, and steel in many building types. So these are some of the innovations that we're going to talk about, that I'm going to show. You know, nail laminated timber, dowel laminated timber, glue laminated timber. You guys might already be familiar with cross laminated timber, and then there's LSL, LVL, and then there's the wood concrete composite. And so you guys are probably thinking, well, wow, I didn't realize there's so many different options of mass timber out there. Well, there are. It's not just cross laminated timber. There's other solutions out there. And the thing with cross laminated timber is that it's you know, it's being shown more. You know, it's being marketed more heavily. And so that's probably why you're a little bit more familiar with cross-lam than some of the other options available to you guys. So Nico, before I get into the mass timber products here, are there any questions that have kind of popped up yet?
Yeah, you have a question about the acoustics of the floor assemblies.
Okay.
How did they achieve high acoustics controlled floor assemblies?
Okay, so there's many different solutions, and we've partnered with a company called Acoustitech, and they have different type of solutions like matting solutions. And so a lot of times when you're building, when you're using these mass timber panels for floor structures, generally you're going to add a layer of either gypcrete or concrete. And so by using the gypcrete or concrete, depending on the thickness, that'll help you achieve the acoustic rating that you require. So with the floors, it's there's an IIC classification that you need to meet, and then through the walls and whatnot is an STC classification that you need to meet. And so there's many different types of solutions. So concrete is one of them. And different types of matting systems. So Acoustitech, you can go on the Acoustitech website and you can look up some of their products that they supply. Nico, I also have Acoustitech's recipe book. So basically, it's a guide that shows illustrations of different floor systems and achieving the different values that you're looking for, right? And so, you know, whether it's a 50 IIC rating or 55 or 60, you can achieve that through different methods, right? So whether it's the matting, or sometimes you may even need to do a drop-down ceiling with some panels, right? Or some gypcrete or drywall, and sometimes, you know, 2 layers of drywall will you know, perform better, kind of thing, right? And so this recipe book has all these different options for you to look at. So if anybody's interested in that recipe book, they can shoot me an email afterwards, and I can send them a link to my Dropbox, and they can have a copy of that for free.
Perfect. And Angel asked, how about expansion and contraction of the material and the fire ratings?
Okay, yeah, good question. So the expansion and contraction, of course, wood does expand and contract. And so a lot of times when the designers just have to design for that. So there are calculations, I don't know them off the top of my head, but there are calculations as far as how much a wall panels will shrink, right? And so generally what ends up happening is the lumber gets brought onto site. The lumber is generally at a 18% moisture content. And then once they frame the wall panels and whatnot, as the lumber dries, it starts to shrink, right? And so there's a calculation of how much to expect, right? And so as the building is drying, the moisture content will come down to probably right around that 12% mark. And so using light frame construction, you would have to calculate that into your design, knowing that it is going to shrink, just so that you can design the proper type of, for example, a cladding for the exterior, your plumbing and your services. You need to take that into account, because as the structure shrinks, you have to make sure that your plumbing stacks and your mechanical stacks compensate for that as well too, right? And so they have what are these for plumbing stacks and mechanical stacks and whatnot. They have what's called like slip joints, and so it allows the plumbing to move as the building moves, right? They also have these type of connectors as well too, metal connectors when they're connecting, for example, to the elevator shafts. If let's say that the elevator shafts happen to be concrete, they have connections that have again slotted connections, slotted holes where they're drilling these angle brackets and whatnot, or these connections into the concrete. But because it has those slotted holes in them, it allows it to move according to the building, to the structure moving as well too, right?
Perfect, thanks. And Sahib asked, are curtain wall and CLT floor intersection details similar to steel or concrete construction? And are there any major differences?
I'm not overly familiar with the way concrete and steel connect, wall panels and floor panels connect. But for CLT, for mass timber, it's it's simple connections, you guys, and it's a lot of the technology is leaning towards these high strength screws. So these ASSI screws. So these screws are what is connecting these mass timber panels together. Simple angle brackets. That's basically how you're connecting these buildings together, right? And so it's a lot, again, which is time savings when they're erecting these mass timber buildings. Yeah, it's just simple connections, man. Simple connections. So if you want to learn a little bit more about connections, my talk isn't on connections, but you can go to MTC, which is they used to be called MightyCon. Now I think they're called Mass Timber Connectors, MTC. You can go there and check out their website.
Perfect. And I had a question. With all those awards, is there any builder or architecture firm that stands out in Calgary?
Yes, there are, actually. Generally we're seeing GEC architecture, wood advocates, huge wood advocates. GEC architecture are the guys that designed the Rocky Ridge Rec Center, Quarry Park Rec Center. They're just doing some fabulous stuff with wood design. Gibbs Gage Architects is another one. Marshall Tittlemore Architects, I believe they're the ones who, Gibbs Gage did that wood atrium on one of your buildings there that have the curved glue lamps. The parkade entrance, that was Marshall Tittlemore Architects. Yeah, there's some really good wood friendly architects in Calgary, and engineers too. ISL Engineering. ISL Engineering does a lot of mass timber engineering, intuitive engineering. So these are just some of the ones that really pop out right now anyway.
Cool, thanks. And yeah, beside that, you just got a lot of support for your for Elon Musk challenge.
Okay, all right. I got some people joining my team. Awesome.
Okay, I'll let you keep going with your presentation.
Okay, cool. So the first one I want to talk about is NLT. And so NLT is it's nail laminated timber. And it's a structurally efficient and economic panel product, which can be used for floors, wall, and roof structures. So basically, NLT is created from dimensional lumber stacked on edge. So you can take your either 2x6, 2x8, 2x10, 2x12, and then you just laminate them together using nails. So you mechanically fasten them with nails. And essentially, they're 1.5 inches on center, right? Now, the thing with NLT is that in order to create a structural diaphragm, you need to add a layer of plywood or OSB sheathing on one of the sides, right? And by doing that, it allows you to have that structural diaphragm that you require. NLT is sanctioned by the building codes and qualifies as heavy timber. So as such, you don't need, it doesn't require an alternative solution to be used in buildings, okay? North American lumber by nature has variations in characteristics like straightness and bow and sweep. And so these are all addressed through a factory quality control process, resulting in the panels which can be relied on to be square and true as the building is put together on site. And so Structure Craft is one of the companies who came up with their nail laminated timber design guide. So I invite you to go to structurecraft.com. This is a free guide. So if you guys want to download this, you just have to register your information and you'll get a copy of this free NLT guide. This is just a project. This is actually 10 years now. This project has been built. This is the Athabasca University. And so they used NLT. It was supplied by Western Arch Rib. Western Arch Rib is one of the manufacturers here in Edmonton. And you could see the roof panels that they created there. And it was really neat because what they did was they alternated from 2x6 to 2x8, 2x6, 2x8, and which created that nice looking fluted design on the roof panels. This is Samuel Brighouse Elementary School. This is in Richmond, BC. Another really neat feature that you could do with NLT is you could see that the curvature of the ceiling. And so this was really neat because they actually built jigs on site, and then they nailed these all together on site so that they can match up with the curvature of the roof line. This is Varscona Theater. This is up here in Edmonton. This is, again, NLT panels for the roof structure, and they also used it for some of the seating and the stage as well, too. Sure you guys are familiar with MEC. Their headquarters in Vancouver. They used NLT quite extensively there as well, too. So DLT is dowel laminated timber. And very, very similar to NLT, except you're not using nails, you're using wooden dowels to connect all the members together, okay? And so you can see that you're able to create some really neat profiles here using DLT. And again, it's, structurecraft.com. They have a dowel lam design guide. So if you want to download that free guide, just go to structurecraft.com, enter your information. This is one of their projects. This is T3 in Atlanta. It's a 7-story, 205,000 square foot mass timber office building. And so they used DLT here. It was, I believe this one was, I think it's 5 stories on one concrete. But you could see that, the building turned out beautiful. The Saudo. This is a 6-story, 120,000 square foot mass timber commercial office building. This is San Antonio's first major mass timber project. Again, 5 floors of mass timber on 1 story of concrete. And that was using the DLT as well too. Next innovation is GLT. Not really an innovation. It's actually been around for a long time. However, generally what we're using these for is it's basically manufactured the same way as a glue lam beam, except this time it's turned on its side, right? And so it's manufactured to the same high standards as glulam, and it's basically guaranteed to possess the same long-standing history and durability as glulam. And so you can see, you know, some of the manufacturers in the West here. There's Structurelam, they're out of Penticton. Western Archib, as I mentioned, they're based here in Edmonton. And Nordic Lam also produces it out in Quebec. And these panels are produced in 2-foot widths and you know, 3 1/8 inch, all the way up to 8.5 inches deep and up to 66 foot lengths. So if you guys want more information on those, go to westernarchive.com. Here's one of their projects that they used the GLT on is the Mosaic Center for Conscious Community and Commerce. This is in Edmonton here. Beautiful hybrid building, steel frame with west deck roof panels and floor panels. Turned out to be a beautiful building. Next innovation is CLT, and I'm sure you guys are most of you guys are probably all familiar with CLT. Basically, it's wood panels typically consisting of you know, 3, 5, or 7 layers of dimensional lumber. And what happens is they're oriented at right angles to one another and glued and pressed to form structural panels with exceptional strength, dimensional stability, and rigidity. So because of CLT's structural properties and dimensional stability, the mass timber product is well suited for floors, walls, and roofs, and used extensively in mid-rise construction and tall wood buildings. CLT can be manufactured to customized dimensions, and panel sizes vary by manufacturer, while the length is usually limited by transportation restrictions. What's neat about CLT is that here in North America, FP Innovations developed this CLT handbook. So basically, this handbook allows you to, you can essentially design a CLT building just by using this handbook, because most of the manufacturers have to design and produce to this standard. Okay, whereas in Europe, where CLT was created, you know, 20, 25 years ago, 30 years ago, each of the different manufacturers consider their CLT as a proprietary product. And so each one of theirs has different design values. And so they have to have their own engineering teams design their products over there, right? So this is Structurelam, based out of BC, one of the major producers of crosslam. Nordic Lam, they're out of Quebec. And here's another opportunity. So if anybody, you know, once we win that 50 million from Elon, what we'll do is we'll take 10 to 15 million of that, and we will build a mass timber manufacturing plant, because the demand in the US is going to be so tremendous that you know, the producers that are online right now are not going to be able to keep up. And I'm going to show you some numbers here, okay? And so you could see that a lot of these, there's going to be a lot more of these CLT and mass timber manufacturers popping up. And so on the left, this is Element 5. They're out of Ontario. Top right is Kolesnikov. So they're producing CLT now, and they're out of BC. Bottom right corner is SmartLam. They're out of Montana. On the left is DR Johnson Wood Innovations. They're based out of Oregon. Frere's Lumber, top right, is also out of Oregon. And then Vegan Timbers, also producing CLT. They're based out of Washington. And Katera, the Katera Group. These guys are massive, man. They're man, they just got some really deep pockets, and they're buying up everything. So they bought I'm sure you guys have heard of Michael Green. Michael Green Architecture, they bought them. And they also bought Equilibrium Engineering. So two of the biggest wood advocate firms that you could think of here in Canada were bought up by this investment company, Katera. And so now now they have the whole team, they have a whole system where they're designing these mass timber buildings. And they have a lot of money invested in a lot of their manufacturing plants. So they actually have a plant online now that is out of Spokane, Washington. and they're producing CLT out of there. And so a lot of it is automated. They use robotics and automation. And so, generally when you're thinking about wood products, you're thinking, forestry, you're thinking these lumberjacks, with these big beards and an axe. That's not the case anymore, man. This is like new technology, and a lot of it is highly automated. So there's not a lot of people on the line. You have a lot of the labor force is actually in the office doing a lot of the designing and preparation and whatnot, right? And a plant like this, you might need only, a handful of guys, maybe 6 or 7 guys to actually run a plant like this, right? So this is one of the examples. This is the Fort Mac Airport. They used CLT for the roof panels there, you could see. Now they spaced them out. They left that space there, and that was to run services. So they're running their electrical, they're running their sprinkler systems, and some HVAC and whatnot through those cavities. So you could see that you could still come up with some really neat designs and still be able to accommodate the services, right? This is in Calgary. This is a full wood building. This is the new Brighton Middle School. And so they're using glulam beams. They're using CLT floors. They have, they're using dimensional lumber for the walls. Next will be the LSL panels. And so these are laminated strand lumber. And so typically laminated strand lumber are, they're typically used as beams, okay? And so these panels are manufactured similar to the way they manufacture beams and columns, which are made by shredding wood from fast-growing trees, low-value hardwood logs, such as aspen, birch, and poplar, and into thin strands, right? And then what they do is they orient these thin strands for maximum strength, and then they glue them together into these long billets using a steam-injected process. Okay, and so normally what would end up happening is they would take these panels and then they would rip them down into beam sizes, right? So 9.5 inch, 11/7/8 inch, 14 inch, 16 inch into beams. But instead of doing that, they're manufacturing these from 4-foot panels up to even 8-foot panels, and they're using them for floors and roofs. Due to somewhat random strand arrangement, LSL panels provide a really unique architectural aesthetic. And so it was used in the Civic Center in North Vancouver. And so you could see that they, they sanded down the product. They put a really nice varnish on it, and they used it quite extensively for this building here. Next innovation is LVL. Again, not a new innovation, however, a new way of using it. So LVL panels are made from peeler logs, basically in the same production line as LVL beams. They're engineered to precise design values with a very high strength to weight ratio. LVL panels are suitable for structural walls, floors, and roof applications. And so similar to LSL, they're manufacturing these. Normally they would rip them down and use them as beams, but they're using them as floor panels and roof panels. So with the increasing interest in mass timber use for diaphragm applications, manufacturers are beginning to position LVL in full sheet formats. In typical manufacture, all veneers are laid up, so the grain direction is the same in all veneers, with the grain basically parallel to the span. So this is a beautiful roof structure that was built in Seville, Spain. And I believe Jesus went and visited this place. Anyway, the image is really neat because you can see it's like this really large wooden canopy in the middle of a concrete jungle. And so, typically they're, for generations, their culture is, building with brick and mortar or concrete or masonry, right? And so to have this big, huge wooden roof structure in the middle of their city is actually really, really neat. And so it's a public space, really neat looking space. They have they hold like these big, huge dance parties and whatnot in underneath the canopy there. Last thing we're going to talk about is the wood concrete composite. It's a technology which focuses on optimizing performance and material requirements by engineering a structural connection between the timber and the concrete components. Okay, so structural efficiency is gained by creating that composite action between the two materials. So this hybridization basically enables designers to reduce the cross sections and increase their spans and streamline structures in pursuit of sustainable architecture. So wood concrete composite panels can be used as floor panels or wall panels, and either timber panels or beams can be used. And there are many methods of creating composite action between the timber and the concrete. So the options, one common option is to use diagonal incline screws, basically half drilled into the timber elements and left protruding into the concrete topping. And that's once the concrete topping is poured, it's poured onto the screws, and that's what creates the composite action. There are other proprietary connectors available, including this one, which is the HBV steel mesh connector. And so you can see what they do is they slot out all these grooves into the timber panels, and then they epoxy these mesh connectors into the timber panel, and then that's how they're locked in there. And then once they pour the concrete on top, the concrete interweaves in between all the holes in the mesh, and that's how the composite action is achieved. This is one of the examples where it was used. This is on UBC, Earth Science building. And so we're running out of time, so I'm gonna try to whip through the tall wood buildings real quick here. We think where mass timber is gonna be best utilized would be in tall wood buildings, okay? And so you could see here, our counterparts down in the US WoodWorks group, they come out with, they assist and they track all these mass timber buildings that are being designed or built. So in December of 2019, you'll see that there were roughly 708 mass timber buildings either have started construction or in the design process. And in December of 2020, you could see that number jumped up to 1,060. So during a COVID year, there was still 300 new mass timber projects that are either in the works or in design. And so you can see that there is, that's where the opportunity is, man. There's tons of opportunity with mass timber across Canada and the US. Tall wood is happening around the world. And there's this global revolution. And what we want to do is we want to change the world one mass timber project at a time. We know that wood is a competitive option for tall wood buildings because it allows for faster and safer on-site construction. These prefabricated sections can be manufactured off-site, shipped to the project, and then assembled on-site, significantly shortening the project timelines and improving safety and accuracy. Allows for tighter envelopes, excellent fire resistance ratings, and excellent structural and seismic performance as well too. Some significant advantages, the ability to build higher in areas of poor soil as a superstructure, and foundations are lighter compared to other building materials. Quieter to build on site, which means that the adjoining neighbors are less likely to complain, and basically workers are not exposed to high levels of noise. The worker safety during the construction can be improved with the ability to work off of large mass timber floor plates versus steel joists or even eye joists. They're kind of flimsy, so it's easier for the workers to work off of these massive large panels than it is for individual pieces, right? So as you could see, timber's looking up, and there's a race basically to the tallest. So with our recent code changes in the NBC, Alberta has already adopted the 12 stories in Canada. Alberta is one of the first provinces to actually accept the tallwood provision. And BC is a little bit different. Vancouver has accepted it, but the BC government has not accepted it as a province. But what they're doing is the BC government has said, okay, well, if any of the municipalities want to use or build 12 stories in BC, we'll support you, but we're not taking responsibility. So that's kind of their stance, but hopefully this will eventually roll out nationwide. In the US, they're going to be able to build up to 18 stories in the US. So again, some big opportunities over there, you guys. Now, I need to first mention Michael Green's concept, which is the FFTT, which is finding the forest through the trees. Michael Green was the first to do a comprehensive analysis on tallwood buildings, environmental, structural, seismic, fire envelope, cost, and it was all documented in the case for tallwood buildings, that was released back in 2012. So really, that's the study that really kicked off the tallwood buildings race to the top, really. These are some of the concepts for 20 and 40-story wood buildings. I'm just going to kind of breeze through this real quick here. This is the Ho-Ho. This is world's tallest building tower. Now, the Ho-Ho in Vienna stands at 24 stories tall, 276 feet. Okay, so 276 feet. Remember that number, okay? Because, boom, another article, the world's tallest timber building. Oh, guess what? Now this is the tallest building because it stands at 280 feet tall. This is an 18-story structure in Norway. It's called the Mosternet building. Recently opened its doors. It's owned by a big investment group, designed by Vol Architecture of Trondheim. And it's apartments, hotel, restaurant, offices, beautiful looking building. This is Hout. This is already started. This is 21 floors, 55 units. The project name is short for Hout Couture. Comes from the tailor-made design of its 55 apartment units. So you can see it's a nice looking building. This is conceptual plans for the Tratopen in Stockholm. Again, this is just conceptual design. But what's neat about this is you can see that the way they did the facade, they numbered all the floors on the exterior. It actually also provides a shade. So this is really neat. Maybe some design ideas for some of the students working on their capstone. This is Big Wood, US. This is, again, conceptual. This is 20 to 30 stories. This is in Chicago. Timber Tower. This is Skidmore, Owings, and Merrill, 42 stories. Again, conceptual. Again, conceptual for London, 80 stories, 80-story tower. Crazy. Yeah. Another one in Tokyo. Tokyo, this is, again, this is conceptual for 70 stories. Okay, so what about Canada? What's happening here? Well, the latest round of the funding had when I say latest round of funding, it's funding from NRCan. NRCan is giving grants and funding to projects and using them as demonstration projects. And so they're giving some of these projects anywhere up to $5 million worth of free money to help them and assist them with building these demo projects. So you can see on the top left is Canada Earth Tower. It's, right now it was designed as a 12-story, but really it could be taller. And I think they're looking to see if they can reach 30 to 40 stories high. Bottom left is U of T's Goldring Center, 14 stories. George Brown College is already in the works. And then this is the T3 Bayside in Toronto, Ontario. It's a 10-story office complex. This one is already built. This is the Origine. This is a 13-story building in Quebec City. I went and toured this. This is actually an amazing building. It's condos. So this one's already been built. You guys all know about the Brock Commons, 18-story mass timber. This once upon a time was the tallest timber building in the world. No longer, but it did hold that designation for a little while. So it's a hybrid. So you can see that they use the concrete core for the stairwell and elevator shaft, and then CLT floor panels, glulam posts. That's the Brock Commons. And so this is the latest project being built in Vancouver. This is Sugaroo Ban revealed this. This is the terrace house. And so this is under construction right now, and it's supposed to reach up to 71 meters at its tip. Yeah, it's just another beautiful looking building being built in Vancouver. So what's next? Well, we need to continue to support other provinces to adopt the NBC, the National Building Codes, to allow up to 12 stories. Continue to support NRCan with their communication working groups. Continue to support the development of new solutions, which will help reduce the costs and replicability. So I'm going to finish off with this quick little video here, Nico. Hopefully you guys can hear it.
Yeah, it's good. You can hear it.
There's something really wonderful to walk into the forests of Canada, the scale of the trees that you see, and you realize those trees are grown by the sun, and they've done this incredible process of photosynthesis to create the strength that they've created over their lifetime. Respect for the tree and its life is something that I believe is part of the respect we put into the architecture of building with wood. Wood resides as the material of choice to make a difference in the quality of our buildings from an environmental point of view. And so now we're sort of blasting into this era of technological innovation in wood that we've never seen before.
I think there's a connection that people have, an understanding about wood that is different. Wood structures really have an unlimited lifespan. We took pieces that were 50 years old out of this building. We even took some wood out of a school in Canmore that was 30 or 40 years old, refinished it, refurbished the components, re-engineered it, and they're virtually as good as new. And that's something that you actually can't do with steel and you can't do with concrete. There's also a real need to have the building fit into the environment here. Building buildings with natural materials, building buildings out of wood, stone, using natural materials that fit the mountain environment. The building needed to feel like it belonged in this place, and it was part of the community and part of that heritage. From a recyclable point of view, wood is vastly superior to other forms of construction.
I think all Albertans have a sense of pride with regards to our industries, and certainly the forest industry, but those of us that live and work in forest-based communities really have that pride because we see firsthand the great work that they do. It's amazing how many jobs that are created in Alberta from the forest industry. We have over 18,000 jobs in the industry, creating economic benefits for Albertans of about $4 billion. So it's a wonderful industry for this province, and we can see that the benefits in jobs, in economic development in our communities is a huge benefit to this province.
Rather than use steel and concrete, which really don't have good environmental footprints and have very high carbon footprints for greenhouse gases, what we need to move towards is wood, which doesn't. It has a much better environmental message as long as it's sourced from sustainably managed forests that we have here in Canada, and therefore it's really always the right choice of material.
Just want to thank some of our key funders and partners. And with that, I'll take some questions. Sorry, I went a little bit over there, Nico.
Oh, no problem. It doesn't seem like there is any more questions right now. I'll maybe give a few minutes if anyone has questions or want to turn on their mic even.
Yeah, if anybody needs any kind of support or whatnot, or if they wanted any of those resources that I had mentioned, they can shoot me an email. My email is up on the screen right now.
Yeah, perfect. Thank you, Jerry. And yeah, that was really inspiring. And thanks everyone for coming to the presentation. Great.
Thank you, Jerry and Nico. Appreciate it.
Thank you.
Thanks. See you, everyone. Bye.
Thanks, Nico.